Hi there, senior high school students. Welcome back here on my channel. This is Teacher Jinjin, your virtual teacher here on YouTube. This video is for grade 11 General Mathematics. Our topic for today is all about functions. These are the following objectives in this lesson. Recall the concepts of relations and functions. Define and explain functional relationship as a mathematical model of situation, and represent real-life situations using functions. This lesson will give you the practical application of functions in a real-life scenario, including the piecewise function. When you were in grade 8, you already encountered relation and function. But in this module, let's take into a deeper sense on how this topic can be useful in our daily life. Are you all ready? Let's get started. What's in? Before we proceed in representing real-life scenario using function, let's go back to where we start. What have you remembered about relations and functions? A relation is any set of ordered pair. When we say ordered pair, we have x and y coordinates. For example, we have set A equals 0, negative 3, negative 1, positive 2, positive 2, positive 2, positive 1, 0. This is what we call a relation with a set of ordered pair. The set of all first elements of the ordered pairs is called the domain of the relation. So here are the following domain of this relation: 0, negative 1, positive 2, and positive 1. These are the domain of this following set. And the set of all second elements is called the range. So here are the following range in this set: negative 3, positive 2, positive 2, and 0. Again, all first elements of the ordered pair is the domain, and all second elements is called the range. Alright, let's move on to a function. A function is a relation or rule of correspondence between two elements such that each element in the domain corresponds to exactly one element in the range. Take note of this: each element in the domain corresponds to exactly one element in the range, meaning the first element or the domain must not be repeated. To further understand function, let's study the following. Given the following ordered pairs, which relations are functions? You can pause the video and play it after you are done answering. What is your answer? You are right. A and B are functions because each element in the domain corresponds to a unique element in the range. So these are functions. Meanwhile, relations C and D are not functions because they contain ordered pairs with the same domain. Let's see. In relation C, we have 0, positive 1, 0, negative 1. Which means these ordered pairs have the same domain, and this is not a function. Meanwhile, in set T, we have here AB, BC, CD, and AD, which means the domain is repeated, and this is not also a function. Okay, so there are different ways to represent a function. We can represent it as ordered pair, and we can also represent it as a table. These are following relations, but which relations shows a function? Is it A, B, or C? You can pause the video and play it after you are done answering. Are you done? What is your answer? That is right. A and B are functions since all the value of x corresponds to exactly one value of y. In letter A, we have 1, 2, 3, 4, 5, 6. So, there are no repetition of x values. In letter B, we have 4, negative 3, positive 1, positive 2, and positive 5. So, there is no repetition of x values. Unlike in table C, we have 0, negative 1, positive 4, positive 2 and negative 1, which means negative 1 corresponds to two values, positive 4 and positive 1. So, A and C are functions, but C is not a function. We can also identify a function given a diagram. On the following mapping diagrams, which do you think represent functions? Let's see. In letter A, we have A corresponds to X, B corresponds to Y, and C corresponds to Y. As you can see, B and C corresponds to Y, and this is what we call many-to-one correspondence. Is this a function or not a function? That is correct. It is a function because A, B, and C are not repeated. How about letter B? Is it a function or not? Let's see. So X is being paired with A, and at the same time, it is being paired with B. Then, Y is being paired with C. This is what we call one-to-many correspondence because X is being paired to two values. Is it a function or not a function? That is correct. It is not a function because A and B is being paired with the same domain X. So this is not a function. How about letter C? We have here Jana is being paired to Ray, Donna is being paired to Mark, and Maya is being paired to Ken. And this is what we call one-to-one correspondence because every element in the domain corresponds to every element in the range. Is this a function or not? Correct. It is a function because each element in the domain corresponds to a unique element in the range. Always remember this. One-to-one and many-to-one can be a function, but one-to-many and many-to-many cannot be a function. A relation between two sets of numbers can be illustrated by graph in the Cartesian plane, and that a function passes the vertical line test. A graph of a relation is a function if any vertical line drawn passing through the graph intersects it at exactly one point. Using the vertical line test, can you identify the graph or graphs of function? Let us try letter A. Is it a function or not? Correct. It is a function because it passed the vertical line test. How about letter B? Let's see. Is it a function or not a function? You are right. It is not a function because the line intersects at 2 points. Okay? How about letter C? Is it a function or not? Let's see. What do you observe? Does it pass the vertical line test? Correct, meaning to say this is a function. How about letter D? Let's see. Is it a function or not? As you can see, the vertical line intersects the graph at 2 points. Okay, do you understand? Again, a function passes the vertical line test. But the graph is not a function if the vertical line intersects at 2 points. In mathematics, we can represent functions in different ways. It can be represented through words, tables, mappings, equations, graphs, and ordered pairs. We said that for a relation to become a function, the value of the domain must correspond to a single value of the range. Let's read this following scenario. As part of the requirements in statistics class, Andre made a survey on the religion of his classmates, and here's what he found out. Andre said, "Good morning, classmates. As our requirement in statistics, may I know your religion? This data will be part of my input in the survey that I am doing." Anna said, "I am a Catholic." Also, Kevin said he is also a Catholic. Sam is a member of Iglesia ni Cristo. Joey is a born-again Christian. Lani is a Muslim. And Jen said she is a Catholic. For you to understand, let us represent this as a map. So Anna is a Catholic, Kevin is a Catholic, Sam is INC, Joey is born again, Lani is a Muslim, and Jen is also a Catholic. Religion is an example of function. Inside the classroom, 3 classmates said that they are Catholic. This shows a many-to-one relationship. Classmates being the domain and religion being the range indicate that different values of domain can have one value of range. One-to-one relationship was also illustrated by the classmates who said that they are born again, Muslim, and Iglesia ni Cristo. Can you cite other real-life situations that show functions? Comment down below. Function can be illustrated as a machine where there is the input and the output. When you put an object into the machine, you expect a product as output after the process being done by the machine. For example, when you put an orange fruit into a juicer, you expect an orange juice as the output and not a grape juice. Or, you will never expect to have 2 kinds of juices, orange and grapes. We have also learned that a function can be represented by equation. For example, we have here an input 16 and we have a process times 4 and the output is equal to 64. So, we can always represent mathematical relations as machines with an input and an output, and that the output is related to the input by some rule. Let's try the following real-life situations. Letter A. If height or age is a function of age, give a function h that can represent the height of a person in age if every year the height is added by 2 inches. Since every year the height is added by 2 inches, then the height function is h of a equals 2 plus the age. Letter B. If distance is a function of time, give a function d that can represent the distance a car travels in time if every hour the car travels 60 kilometers. Since every hour the car travels 60 kilometers, therefore, the distance function is given by d of t equals 60 times t. Lastly, give a function b that can represent the amount of battery charge of a cellular phone in hour if 12% battery was lost every hour. Since every hour loses 12% of the battery, then the amount of battery function is b of h equals 100 minus 0.12 times h. Why is it 0.12? Because when you convert 12% into decimal point, you will get 0.12. Please try to answer these following assessments for you to check your understanding about our lesson for today. You can pause this video and take a screenshot of the question to answer later when you have available time. This is for items 1 to 3. Again, you can pause the video or take a screenshot. The next set is for items 4 to 7. Next, we have 8 to 10. And that's it. We are done with our first lesson about functions for our general mathematics subject. Great job for today! Please do consider subscribing and click the bell button for you to be updated on the next videos. If you like this video, please like and comment down below. This is Teacher Jinjin. See you on the next lesson. Bye!